Hey everyone. Hopefully everyone can hear me. Shoot a thumbs up in the comments if my audio and video is a go. We'll kick off in 1 minute. Um, all right. Welcome to the Stamp live stream. My name is Tom Wilson, and I will take us through about an hour of this V1 of Stamp. And I'm very happy and excited to share this. I've been working on this protocol for the past 8 months, and I am pleased to say that early next week we will be shipping V1 of stamps, which is a completed contract and token. And more to come on that early next week. But today I just want to kind of give everyone an update on what it is and go through the developer SDK and a code review of the contract. Again, welcome everyone's eyeballs on the contract. This will be published early next week, and then it's there forever because the permaweb is forever. So, really would love any comments or feedback on that um, at this point. Thanks for everyone hitting the comments. Just feel free to post questions as I go. Um, the introduction to stamps. So, Chat GPT helped me come up with this acronym: signature, timestamp, and metadata protocol. The basic core of a stamp transaction is an Arweave transaction. That Arweave transaction is signed at a given time, and um, there's a couple of tags on the transaction that make it a stamp. Protocol name as stamp, and then data source. And this is the transaction identifier that the user is stamping. This is the digital asset. So signature, timestamp, and metadata protocol. Stamp. So what can I use stamps for? Go through some basic use cases for stamps. So stamps is the ability to take any digital asset or really any Arweave transaction and do what I like to call proof of attribution, or it's easy to think of as a like to really appreciate that content, whether that content is a video or a blog post or um, a music file or an application. Anything on the permaweb can be stamped. So here are some kind of use cases that could be used for stamps, and the first one's kind of a content ranking and discovery kind of use case where developers can use Stamp to implement a ranking system for content on the permaweb by allowing users to stamp their favorite content. Also, incentivize content creation. Stamp introduces a tradable reward for content creators whose work receives significant number of stamps. And then this produces high quality and engaging content. Community voting and engagement. Stamp can be used to facilitate community voting and applications that allow users to express their opinions and preferences by stamping the content they support. Reputation systems. The Sybil component of Stamp helps establish human verification and authenticity of stamps. This can be utilized to build reputation systems where human verified stampers hold more weight than for determining content. Decentralized content platforms. So Stamp can be integrated into a platform to enhance their functionality. By incorporating the protocol, platforms can implement content curation, rewards, etc. Tokenized social media platforms. Social media platforms can leverage Stamp to introduce tokenized engagement. And then gamification and rewards. And I'll try to explain some examples of these, but the last one, gamification rewards, we actually did a neat project at ETH Denver where we had hoodies, these orange hoodies at the Ford research booth. And in order for anyone to get a hoodie, they had to find 3 other people that had the orange hoodie with a QR code on their system, on their hoodie. And you used your phone and camera to scan that QR code and effectively stamp that hoodie. And if you stamp 3 of them, you got your own hoodie with your QR code. And that was a lot of fun. And people that engaged in the game really enjoyed that. So those are just kind of some use cases. And there's probably more use cases out there that you can use Stamp for. So hopefully that gives you an idea of how stamps can be used. It is fully decentralized on the permaweb and is really built to enable developers to add this information easily into their applications and platforms. Stamp is permanent. The goal is to be useful, complete, and scalable. So through these 8 months, we've really focused hard on these 3 missions, right? We wanted it to be useful, to have meaning, and be easy to implement, composable. We wanted it to be complete. So the big idea with this release is this is the last release of Stamp as far as functionality. So V1, we're going to push this out there, and we have a 90-day window to fix any bugs. But after that 90 days, the private keys are going to be thrown away, and it's there with documentation and tools, etc. And scalable. Scalable was probably the hardest one to crack, and I believe we've got a really good solution. And basically, the scalability is comes down to 3 components. The core component is the scalable component. So it will always be as scalable as Arweave and Bundler. So Arweave and Bundler have been proven to have very, very high reads and 50,000 transactions per second capabilities. And everyone believes, based on the architecture, that it can go much larger than that. It's just the amount of how many machines that you're willing to put into that. So the core stamp protocol is really just writing Arweave transactions with metadata tags, right? The protocol name as stamp and the data source that you're pointing to. The second component is Sybil resistance, right? So Sybil resistance is what we can use to protect or prevent bots from uh, skewing the value curation, and using an organization like VouchDAO, which has services that allow wallets to get vouched, uh, can greatly um, provide that proof of human or prevent Sybil attacks on the system. And the way that this works is not on write, but on read. So through Stamp.js library, it will do a read and read all the stamps for a given asset on Arweave. And then it'll also do a read for all of the stamped addresses and make sure that they're vouched. And you'll get two counts. You'll get a total count of all the wallets that stamp the content, and you'll get a vouched count. And the vouch count can show uh, which of those transactions or those stamps were vouched. So you have both metrics as a developer. And then finally, we built a reward system and a stamp token on Warp SmartWeave that's using a PST and the FCP 2.0 protocol. So it is built to interchange with other tokens on the system and to provide a way for um, uh, people to add super stamps where they can submit tokens to creators, and creators can monetize their content without having to keep it private. So the whole basis is to really encourage open composable data. So, with this quick intro, I really want to give a shout out to all the integrations that we've done with stamps through this 8 months of testing. I won't go through all the names, but I'll call out the Permafax team, the Alex team, incredible to uh, uh, get stamps integrated. Also, After and Wiki and R Academy and Hibiscus. Also, Permatweet. Permatweet, you can go and add or stamp your permanent tweets that you archive. We want more. We want more PermaWeb apps to integrate. So if you're interested in stamps, please reach out, and I'll be happy to work with you to integrate it. And through this presentation, hopefully you can see that it'll be pretty easy to do. Um, quick question. Depressed MetaB asked, can you monetize without Superstamp? So when you enable stamps for your asset, every 720 block heights, a reward cycle will kick in. And that reward cycle will look at all of the stamp content during that 720 blocks, or really a day. and it will run through a reputation algorithm to look at who stamped it and essentially distribute a minted set of stamp tokens to all the content users who had stamped digital assets. And as those content creators receive those rewards, they would be able to trade those for other tokens in the marketplace. So that is another way that users can monetize that. Thanks. Thanks for the question. So we've got a good bit of integrations, and if I did miss you, please let me know. I'm happy to continue to add you to the list. A big shout out from Permapalooza, hunt.gateway.io with help from RIO was a lot of fun. So throughout the day at Permapalooza, there was QR codes everywhere, and they were tied to Hunt, which was a stamping game. So all the participants got to stamp the QR codes and see a leaderboard, and it was a lot of fun. So you can have a lot of fun with this very simple protocol, if you will. Okay, so the last bit of the intro is just a huge thank you to all of the community members that went through this crazy testing cycle with us. Thanks to everyone that has integrated stamps and everyone that has stamped content. Here's a few to call out. Only Are We been incredibly supportive through this process. He has a great podcast, PermaWeb Pioneers. Highly advise you to check that out. And I think has some really neat community events coming out. So go to community.gateway.io to check that out. And DMAC, who's a huge supporter in the community, Pearson Lucas, Justin Shaw, Rohit, Damon, and Almost Great. Huge thank yous to all of you guys who have really provided not only incredibly great feedback, but also participation in this. So again, if you want to check out everyone that participated, you can go to explore_stamps.gateway.io, see a leaderboard, and you can click on the little eye next to them and see what they've stamped, which is really cool. And I think is worth checking out. And I think we'll see in the future more kind of social kind of applications coming out around this stamping kind of protocol. So that is kind of the high level intro. And now we'll go into a little bit of technical developer focused pieces of this presentation and talk about code. So if you don't care to listen or see code on the screen, I hope you have a great weekend. Thanks for coming in. And for everybody else that's interested in looking at some code and talking about some code, just stick around because I think it'll be fun. The first thing is Stamp.js. Stamp.js is a library for integrating stamps. It's an NPM library. And what we're going to do is just kind of go through the API so that everyone can get a good idea of just how simple it is, hopefully, to implement and use. The goal of stamps is to be very powerful, but very simple at the same time. Just not a lot of complexity in terms of the integration and the usability. So the requirements is that you need Node.js and npm or yarn or pnpm, etc. Anything that can connect to npm. and then you install with npm install at permaweb/stamp.js. Pretty simple, straightforward. And this next release will have 0 dependencies. So the previous or the current release out there has a couple of dependencies. We're going to remove that. We don't need dependencies in this library. And one that we'll be removing is warp, which will be nice. Warp is awesome, uh, but I think having a library without dependencies is more maintainable and sustainable. And yeah, I think you'll like what we're doing. So to init stamps, once you've installed it in your project, you just import it, and then you just run stamps.init, and that creates your stamps instance. Pretty simple. And now registering. So there's a couple ways that you can register a digital asset for stamps. One is if it's an atomic asset, if you deploy your data as an atomic asset, which basically means it has a contract connected to it, um, then you have either an owner or a balances object in that contract, and then it's immediately registered. You don't have to do anything else. But if you want to register something that's not atomic asset, you can do that too. And the way that you do that is this register function. And what I am showing is just a regular Arweave transaction, but this register function will work with a bundler transaction as well, or a warp transaction. Um, what you would do is create a transaction like we would normally do, and then all the stamps library does is it just maps the stamp tags, the two tags that it needs to stamp associate the asset ID and the stamp protocol name. So it's just just a couple of tags, and then it returns that to your transaction object, and then you can sign and post it, or you can send it to a wallet to dispatch it, etc. So it's pretty straightforward and easy to do if you want to register, kind of just a standalone transaction that does not have an atomic asset. And in that case, when you do register it, the actual signer of the wallet becomes the owner of that transaction. So whoever owns that transaction, whoever signs this transaction, will receive the rewards as people stamp it. The other method in the library is the stamp, right? So very simple. It is a promise-based function, so we'll await it and then we call stamp and pass the transaction. Really straightforward, really easy to use. Um, the next one is super stamp, and super stamp is really just an extra argument on the stamp method. So you send the transaction and then you send the quantity. And the key here is the wallet that's connected to this. And this library runs in the browser, so it's looking for Arweave wallets, the Arweave wallet object that's attached to the window. Um, and when you run it, the wallet that signs this transaction will need to have the quantity of stamps in order to send the stamps, right? So it's a transfer transaction. So if the wallet, only has one half stamp and it's trying to send a super stamp of one, then it will fail, right? So one thing to keep in mind, though, the balances of stamps are 1 to the 12th. So that means the actual unit which we're calling amps, right? Because it's a piece of stamp. So if you take the ST out, you have amps. So the amps are uh, one with 12 zeros is one stamp. So whatever that number is, 1 gajillion or whatever equals one stamp. So it's very similar to R and Winston. So each Winston, it takes 1 to the 1 plus 12 zeros to equal 1 R. With stamps, it takes 1 with 12 zeros to equal 1 with 12 zero amps to equal 1 stamp. Hopefully I said that right. Um, and Lewis asked a question here. The stamp method can only be used for atomic assets, right? And that's a great question. The answer to that question is that the stamp method can be used for any transaction. So if the transaction's atomic asset, then the reward process will be able to look to see who to distribute the rewards to. If the transaction, digital transaction that you're stamping is registered, then the stamp contract will be able to look at the wallet address of that transaction to see who to distribute the rewards to. If the transaction is not an atomic asset or not registered, you can still stamp that transaction. It's just no rewards will go to anyone because there's no one to give the rewards to. Um, which the interesting thing with this new contract is if those transactions are stamped and they don't have an owner assigned to them, those rewards will actually go into the contract treasury for future rewards. So they'll just get recycled, so to speak, which is kind of cool. Thanks for the question. As a follow up, can you super stamp on the register? So, yes, you can't super stamp on the register because it really won't make a lot of sense because you're basically, when you register it, you're the creator signing it. So you would be like passing stamp tokens to yourself. So while that could be implemented, it may not make a lot of sense to do that. Um, but definitely happy to discuss that further if if I'm missing something there. But thank you for the question. Cool. So that's super stamps. And then the last bit of the API is I need to get the counts, right? So when you're building an app, you want to show how many people have stamped your asset that you're looking at. And there's two simple methods. One is a straight dot count. You give it the transaction and it returns an object with the total count and the vouch count. So the total could be 100 and the vouch could be 89. And as an application developer, you can kind of choose which one you want to show, or you may want to show both. If you're in a reputation system, maybe you only care about the vouched. If you're, building more of a general purpose thing and you want everyone, stamp the world, you may only care about the total. So you can kind of choose. Then the other one is an aggregate. So Alex has a list of all their artifacts and they can show who stamped each one in that list. And by doing that, you can just send an array of transactions to stamp.counts plural, and then it'll return an array of each transaction and its total and vouched object. So you can display those and you only have to make one call, no for loops, and you get that information back. So pretty straightforward to get counts. Um, Cool. Okay. So the last bit of this presentation is going through the contract, and I'm going to try to swap screens because we're going to go into Visual Studio Code and really just kind of poke around the contract and talk about some code. And there's two reasons for this. One is I would love to have an extra pair of eyes on the contract and additional comments. Other people have looked at it, been working on this for 8 months, so that's good. But then the other thing is also potentially to provide some guidance to other people that are building contracts, and some things that me and some other colleagues have learned through this process of working with Warp and building contracts. So hopefully a little knowledge share as well. So with that, I'm going to stop this screen, and I'm going to try to share another screen. Okay, cool. So this is the stamp V1 contract README file. And we go, and hopefully the font is okay. Maybe I'll bump it up one. Hopefully you can all see that pretty clear. Um, and before I jump in, let me ask a question. Or answer a question. So Nick says, what about a featured artifact section on Alex showing a list of artifacts ranked by stamps? Um, yep, I think that is super easy to do. Happy to talk to you about how to do that. But yeah, I think uh, when you think about stamps and that kind of convergence of quality, that can allow you to build features like that in your app pretty quickly and easily. So I think that's a great suggestion. Cool. So let's look at some code. Um, Again, this is all in functional JavaScript, so there may be some things that are not super clear, but I think you'll get the gist. Um, so with a contract, Warp contract, it starts with a handle function, and that handle function takes state as one argument, and then the action as the other argument. The action is the interaction that's written to Arweave, and the contract is lazy evaluated. So it's evaluated on read, not on write. And thankfully, with tools like Warp Sequencer and Bundler, the bundler.network service, it makes this process extremely fast. So if we look at our source for this contract, we've got our index.js file, and then we have a read folder that has all of our read methods and the write folder that has all of our write methods. These all get combined together into a single JavaScript file. So when you deploy your contract, you um, you push that JavaScript file onto Arweave itself. So that contract is permanently available, which is kind of cool. If we go into our index.js file, you can see where we're importing all of our functions. And then I've actually got this evolvable constant. So as this launches, I'm giving myself 90 days to update the contract. And then after that, it's game over. It's locked, which is kind of fun, I think. But we start with our handle function. And what we're doing is we're using dependency injection to take all the side effects that we deal with and inject them into each function that we need so that we can really test each function in a pure state and keep everything reliable and consistent. So we're using VouchDAO as our contract for services. Read state, so we're reading contracts. We're using the block height, the timestamp, the ID of the transaction, the owner, contract ID. And a new feature from Warp is this key value storage store. So one of the concerns with Warp is bloated state, right? So if you're having a token that could have, you know, hundreds of thousands to a million different addresses with balances, et cetera, well, the state can get very hard to pass around. So with the key value store, we can store the balances in this storage bucket and it will allow for the state not to be bloated to pass around. So it's very quick to read on a decentralized network of resolution nodes. So we're implementing that. And then we've got uh, what what I call as cron jobs, and these jobs are actually keyed off on future interactions. So it's a check here to see if the input function is not balanced. So balance is a read function. So I only want my cron jobs to run on write, and how the reward feature kicks off without someone having to push a button every day, which is what we did in test mode, is this kind of concept of a cron job. So what it does is on the state, there's the block height of the last reward that it processed. And then every other write during this time does this check. And if that write is greater than 720 as a block height, then it executes this reward function. And the reward function distributes all the rewards to those who stamped it, clears out the stamp queue, and sets the last reward height in that interaction. So then the game will start ticking for the next cycle. The same thing for credits. And the credits is an interesting feature. So when you send someone super stamps, 80% goes to that content creator immediately. And then 20% gets held in this credit feature for a year. And then they get released to the creator after a year. So it's kind of a way to uh, create a little bit of a sink in this kind of token distribution model. Um, so that's kind of the cron job stuff, and we can look at those functions. And then we've got a switch function that kind of breaks each um, function in the contract. We've got our register function, our stamp function, and the stamp function, just like the API is calling stamps, it's going to do the stamps. And if there's quantity, then it'll do a super stamp. So each one of these is a functional pipe. So you'll see a dot chain or a dot map. It's very much like promises of dot then. So, but basically each dot chain or dot map is just another step in your flow. Um, and then we have our balance. So that returns balance, and transfer, evolve. And you can see we're checking if it's evolvable to allow evolve. If not, doesn't allow it. And then allow and claim. Allow and claim are the foreign call protocol 2.0 that's going to allow it to interact with decentralized trading areas so that you can trade stamp for bar or stamp for foo or stamp for baz, etc., which will be a lot of fun. And that is kind of the core methods of the contract. I'll run through the transfer one because that's a common. Well, let's go through the balance one because that's probably the easiest one um, with a PST because it's a little different with the key value store. And then we'll go to transfer and maybe we'll walk through stamp if we have time. Yeah. Yeah. So one of the Lewis makes a comment that he's wishing that it was a sink of weight. Absolutely, a sink of weight is great, but one of the things about a sink of weight and promises are they're eager, and they can be really difficult to for error swallowing. So an error could happen, and you may not worry about it. So this apologize for the different look, but what this does is it does use, promises and a seek away. It just kind of pushes those side effect calls to the edges and allows your logic to be more pure. So when it's pure, it's a lot easier to test consistently. So yeah, I love a sync away too. But when you're working with contracts and you are putting them on the permaweb, you want to be sure that your logic is very, very consistent and there's no kind of gotchas in there because after 90 days, it can't change. So let's look at the balance function because I think that's pretty simple. Look at that. So we're using this async pipe, which basically is like a lazy promise. And what we're doing is we're doing higher order functions. So higher order functions is where you either take or return a function as a result. In this case, we're taking an environment as an argument and we're returning a function to receive the state and action. And this pattern just makes it super easy without any heavy tools to do dependency injection. So we can inject our environment of all of our SmartWeave pieces, and then we can convert any side effect function into a sink, which is a lazy evaluated pure function. And then we can just go through this pipe. So we start with of, which is the constructor, and we validate. So we validate all the things. And the simple thing here is we want to check and say, is the caller valid, right? Because sometimes maybe this gets called and it's not a valid caller. So we want to reject that. And we want to validate if the input target is set, right? So if you're getting a balance, you want to set the target of who you want to get the balance of. And here we just open that up because there is with a balance, if you're wanting to get a balance of yourself, then the caller is the input target. So we just set that to the action, and then we resolve that, which returns it back up to the pipe, and it goes to the next function. And then in the next function, we do a get where we're calling the key value store with the address, and we're getting a value. And if that balance is not available, then we set it to 0, and then we return the result where the target is the address that we're getting the balance for, and V is the balance. So that's the balance function. Hopefully you were able to follow that. Let's try to go through the transfer function, and hopefully it's not too long to review. But just like the balance function, we're doing a higher order function. We're taking in the environment. And in this case, we're using get and put in the key value store. and then we return a function that takes our handler, our reducer, state and action. And this state and action, we start our chain and we validate it and we inject in this validate function, make it a higher order function. We inject a get, and then it returns a function that accepts the state and action. Then once we've validated it, we subtract the caller balance and we add the caller balance. And while these are two separate functions, what's really nice about this process is because it's lazy evaluated, these functions may appear to execute at different times, but they all execute at the same time. So if an error happens, uh, it will throw it out of the chain back to the index to handle an error. So you can't subtract something and not add it, or you can't add something and not subtract it. So it gets passed back to the index where a catch, and then it handles the error, which generates the error message. So that's a really nice effect of this pipeline is the ability to really control your error handling and keep things atomic. So if we look at our validate function again, it's just doing checks. And it would be nice to have a library like a Joy or a Zod. I love Zod as far as like just checking objects, but the problem with that is Zod is a large library, and it's just a lot of code that you don't need in these contracts. So unless it's super complicated, just doing the checks using conditionals, I think works really well. And there's other ways to do it. There's an either library that's really light that can also make it easy to implement validation as well. So whenever you reject, it's going to skip the pipeline and handle the error. And then when you resolve, it's going to continue the pipeline. So what we're doing is we're testing all of our input, making sure it's valid. And if it is valid, we resolve and go right down to the pipe. So with that, we go to subtract caller, and subtract caller. Pretty simple. We get the balance from the caller, and then we chain that. And if it's not there, it's set to 0, which is nice. And then we put the balance minus the quantity, right? So we're subtracting the quantity on our transfer. We're transferring 10 stamps from Tom to 10 stamps to Nick. So we're subtracting from Tom's balance and we're putting it into Nick's balance. So once we do that, we return state and action, and we continue down our chain to target balance, and we're injecting get and put. And then with the target balance, we get the balance from the key value store, and then we set it to 0 if there's no balance, and then we put the balance into the target that we're sending. So we'll do a put in the key value store for the target address, and we take the balance and add it to the input. And then we return state and action. Cool. And then we return that back out, and it goes back to our index. So if there's any questions, and again, one comment Ash made, Ash Dutt, thanks for the comment. Hyper Videos needs a fresh logo. You're absolutely correct. And I don't know, maybe we should change this to the stamps channel. What do you think? Use our killer stamp logo. Thanks for the comment. Look and see if there's any other questions. Stamps. Um, cool. So we've got about 12 minutes left. So if you have questions, and I'm going to attempt to walk through the stamp code. Hopefully you guys are enjoying this. Feel free to ask any questions about the code. And uh, yeah, so I can pop up anybody. So here's a question from DMAC. DMAC's asking, how does Sylvester get his questions popped up? Basically, I get to pick them out and ask them. So if I missed your question, let me know and I'll go back. But yeah, this is my first time using this kind of interface, and really pleased that it's working out pretty well. So thanks, VMAC. Appreciate that. And then MogulX asked, can I see your allow function? And yeah, I think that'll be awesome. So let's go and look at the allow function. Cool. So with the allow, with the foreign call protocol 2.0, right? If you're, let's say, creating an order, you want to sell something. So you post an order up and you allow for X amount of tokens that you want to sell. Again, I'll use foo and bar. So you have some foo tokens, you know, 10 food tokens, and you want to sell 5 of them for 5 bar tokens. So when you create that order, you call this allow function that'll allow those tokens to go to another person. The allow function takes an environment variable and then grabs the get, put, the transaction ID, and the contract ID. And then it starts off by validating. So most of my methods will be the first thing you see is validation, and then the second thing is action. So I separate those. So it's like all my validations, if they aren't there, then it gets removed. It doesn't continue down the chain. So if we look at the validation for the allow, basically it's doing a bunch of checks for valid quantity, target, make sure it's valid, set the claim to transfer a balance to itself. We don't want that. And then invalid balance transfer. So those are some of the checks. And then if there's not enough balance to allow, obviously that's a final check. And once it's resolved, it returns the state in action. And then the append claimable function. So claimable is an array in your contract. And what it's going to do is it's going to get the balance of the caller, and then it's going to do a put and subtract that balance from the caller. And then it's going to essentially add a claimable record from the caller and with a 2 to the target. So the target can come and claim this balance, which would be kind of the contract of the tradable system. And then the quantity and the transaction ID. So this transaction ID is important because when the contract calls an internal right to claim this balance, they need to send the transaction ID of this transaction. So that's how it's going to know that this is a good claim, if you will. So hopefully that makes sense. Cool. Um, let's pop into the stamp function. And this one's a little bit more involved, but I'll just show the highlights here is where um, basically when you stamp something, you set some tags on it to call an action, and this is the action being called. And the action has a data source tag. So it's looking up the data source tag from the tags of this interaction to know what to stamp, which is I think is really neat because it's like less, you don't have to put a lot of repeatable bits in your input tag. So it's just, and it serves two purposes. The data source, well, it's three. It can serve to count through GraphQL the number of stamps. It can serve as input to your contract, and it can serve as a graph to connect transactions to stamps. And there's an Explorer tool called Microscope, which is really cool, where you can pop in a transaction and you can see every one that stamped it in nodes and see a little stamp card. That's kind of cool. So it's just grabbing the data source, then it validates the input, and then it checks if it's vouched. So it's doing a read contract state to see if this is vouched, and then it updates the stamps queue in the state, and that queue is an object that for each cycle will build up, and then when the reward process runs, it will shrink down or empty out for a queue. So again, to make it more scalable and make it more um, less likely to have state bloat. So there's the validate, there's the vouched, um, and there's the result. So one thing to note is the only way the reward mechanism works is based on vouched users. So if you have a digital asset and it's stamped by 100 non-vouched users, you don't get any entry in the game. But if it's stamped by 100 vouched users, then you get entry in the reward system. So again, that's part of that civil resistance. You want quality, and the tokens are rewarded based on humans, not bots, right? So you don't want someone creating a bot army of stamp bots to attack the network. That's not what we want. So hopefully that made some sense. And with that, the last 4 minutes, if anyone can put a use case of stamps in the comments, I will send you a stamp hat or a stamp shirt with a cool logo. So anybody that can remember one of the use cases that I showed earlier and would love to get some swag, just pop it in the comments and I'll make sure I get you a stamp hat or a stamp shirt. And if you have any questions, and everyone that asked a question, I will definitely get in touch with you and get you some swag as well, because I really appreciate the questions, especially Ash and Lewis. Please hit me up, DM me, and I'll get you some swag. Oh man, I must have done a horrible job at going through those use cases. I don't think anyone can remember one. Not a single one. Or maybe the comments are lagging. Stephen said, I zoned out for a second. There's hats. Yeah, if you can remember one use case that I presented earlier, I'll be happy to send you a hat or a shirt. So just in the comments, just so earlier in the presentation, I listed about 6 use cases for stamps. If you can give me one use case, I'll send you some swag. Vincent, gamification. Awesome. Mogul X, aggregating a feed ranked by stamps. Awesome. Great one. All right. Third world Izzy, correct. A great way for social, for reward engagements on a social platform. And DMAC, this is racist against people with bad memories. Very, very true. Um, but if I would have told you before, it wouldn't be as much fun. Right. Iago says tokenization of social media. Absolutely. Great one. And Greg, I think reputation systems was one. Great one. Reputation systems by Marco. Thank you. Cool. I think we hit all of them. I hope this was fun. I hope you got something out of it. I really appreciate your time. And for everyone, you can get in touch with me at Rackus_me on Twitter. So if you got called out on the comments, just send me a DM or send me a Twitter message, and I'll connect with you and get your information so I can send you this, really nice stamped hat or a stamped shirt or a sticker too. If anyone wants stickers, I've got some stamp stickers as well. Thanks again, and if you are on the Discord, you can find me at Tom dash permapages. I think can't remember, but anyway, or just leave a comment in this channel, and I'll get in touch with you and get you some swag. So thanks. Awesome. Hope you guys have a great weekend, and yeah, just be on the lookout in the next few days, next week, for the final push, and we'll get stamps, you know, in production on the permaweb. So thanks. Have a great day.